Hi everyone. This session is dedicated to remind you about principle and essential information about the measurement and the limit of reading. So normally we should know that we have a lot of units of measurement, and here in this table we have all the prefix uh, or we have the prefixes commonly used to write multiples of units of measurement in words. So we have we have a kilo, we have a milli, we have a micro. So normally we have all the prefixes, and on the right hand side of each prefix we have its equivalent in scientific notation. So normally we have its equivalent in scientific notation with respect to the base unit. The base unit. If we have a meter, so from meter to kilometer, or from kilometer to meter, we have a 10 power 3. Okay, it is more more clear. It is to have and to illustrate these prefixes in this line, this axis, from the smallest prefixes to the largest one. So normally we have here the base unit, like gram, meter, liter, watt, joule, volt, etc. We should know the basics. The basic idea is when going from a smaller to larger. Okay. So normally from moving from we have here, we should know that the larger is located in the left hand side, like kilo, mega, giga, etc. And the smallest prefixes or units are located to the right hand side of the base unit. So normally the smallest symbol, the smallest letter indicate or represent the smallest unit. So moving from smaller to larger, okay, we multiply by 10 minus 3 for each increment. So for each step, we multiply by 10 minus 3. So if we are going to, for example, moving from mega to theta, okay? So we want to move from mega to giga, then from giga to theta. So we are going from the smaller one to larger one, okay? So in this case, we multiply for each step, we have a 10 power 3 minus 3. So we multiply by 10 minus 6. Okay? And moving from bigger, larger unit to smaller one to the next one, we multiply by 10 power 3. So moving to the right, we multiply by 10 power 3, and moving to the left, we multiply by 10 power 3 for each step, for each increment. They ask us here in these exercises how many nanowatts in 3.6 milliwatts. So normally we have the milliwatt as unit, and we want to convert to nanowatt. So normally we are here. We want to go to this one. So normally we have to move to the right as indicated in the green arrow. Okay, two steps. Okay, so normally we multiply by 10 power 6. Easy. So we multiply by 10 power 6 to obtain in nanowatt. And the second one, we want the next exercise, we want to convert from meter to kilometer to megameter. So from meter, we are in the base unit, we have a meter, and we want to calculate it and convert it in kilometer. So normally you want to move to the left. So, and one step, one increment, we multiply by 10 power minus 3, and to find its equivalent in megameter, we multiply by 10 power minus 6. What we mean by the limit of reading or the greatest possible. Normally, the limit of reading is always mostly not indicated. Okay, so it is the last significant figure as definition. In the last significant figure. Okay, so the greatest possible error is equal to the limit of reading times 1 over 2 times 1 over 2. Okay, like here, for example, the last significant figure is 8. So normally two decimal places, so it is a 0.01. Okay, meter is the limit of reading. The greatest possible error is the half of this significant figure. So normally it is 0.005 meter. How to find the limit of accuracy? The limits of accuracy is the plus minus this greatest possible error. And we can have a mathematical statement to find the range of true measurement. So normally we put between these two inequality signs, we put the principal, we put the true number 9.38, and to the left we put we subtract from this number, we subtract or we can use the limits of accuracy. It is 9.38 minus 0.005 to the left, and the plus 0.005 to the right. Okay, so normally we want to imitate and to apply the same basics notations here in the next exercise. So they ask the time taken for a student to complete a task in an aptitude test was measured to be 21 seconds. So the limit of reading here, the limit of reading is equivalent is the last significant figure. So we always search for the last one, or we always count the significant figures from the left to the right. So the last one is 1. So normally it is the unit. So it is the unit because it is the last significant figure. How to determine the greatest possible error in the measurement? So it is the half of the unit. It is 0.5 seconds. What other limit of accuracy? It is the original time and 21 seconds plus minus 0.5 plus minus the greatest possible error. And we have a mathematical statement that shows the range of values within which the true time lies. We have the true time here lies between the lower limit of accuracy 21 minus 0.5 and the upper one 21 plus 0.5. So to obtain the mathematical statement that we are searching for. The maximum error in the calculation. So the maximum error, we can find it like we have, for example, if we have a true dimensions for a rectangle, for example. So we find the maximum error for each measurement, and then we recalculate the measurement using the upper and the lower to obtain 2. Then we want to proceed like that. For example, the length and the breadth of a rectangle were measured as 8 centimeters, 10 centimeters to the nearest centimeter. So calculate the perimeter of the rectangle using these measurements. First of all, okay, the perimeter of rectangle equal to it is equal to the double the sum of the length by the breadth. Okay, so it is equal to 36 centimeter. Easy. Okay, write down the greatest possible error in each of these measurements. So in each of these measurements, the last significant figure is the unit. Okay, so normally the greatest error is 0.5. Okay, it is 0.5. Hence, find the limits of accuracy. For the limit of accuracy for the length is 8 plus minus the greatest error, and from the breadth is the 10 plus minus the greatest error. So normally the lower limits of the true perimeter, the lower limit, we use only the lower length and the lower breadth, okay? The lower accuracy limit, the lower limits from here. So it is 8 minus 0.5, 7.5 for the length, and for the lower breadth is 10 minus 0.5, 9.5 to obtain the lower limits of the true perimeter. The upper limit to evaluate the upper limits of the true perimeter, we use only the upper length and the upper limit for the breadth. So it is 8 plus 0.5 and 10 plus 0.5 to obtain 38 centimeter. Finally, to find the maximum error, we use either this formula or this formula, because it would give us the same value. Okay, so the upper, we can use we subtract the original measurement from the upper limit of this measurement, or we subtract the lower limit from the original measurement. So here I use the maximum error. I use to subtract the lower limit from the original one. So it is 2 centimeter is the maximum error. These are the idea for today. Thank you for listening. Bye bye.